Okay, lesson 55 is Maclaurin polynomials, which we actually briefly mentioned before break because you guys were doing some charts that you had to fill in the information. And I remember you guys had sine or cosine, and we talked briefly. So the idea of a Maclaurin polynomial, well, it leads into the thoughts of like sequences and series, which series is a big part. You were in Calc AB. Series is a big part of VC. That's part of the C part. Okay, so that we're not getting to that. But this kind of leads into it, so it is included in the AB part. With Maclaurin polynomials, the idea is that every equation has a polynomial representation. So every equation has a polynomial representation like this 2x squared plus 3x minus 4. Okay, we're going to do the same thing for e of x here and whatever the bottom one is, cosine x. Now, the idea of Maclaurin polynomial, it's of this form, f of x equals, and you'll notice a naught plus a1 of x plus a2 x squared plus a3 x cubed, all the way up to an x of n. And so notice, like here, a2 x squared, that a sub 2 goes with the power x to the second. A sub 3 goes with power x to the third. And right here it defines how we find those coefficients, how we find those a values. So in order to do a of 0, you're doing f of 0, so 0 plugged into the function, divided by 0 factorial. In order to find a1, you're doing the first derivative at 0, divided by 1 factorial. In order to find a2, you're doing the second derivative at 0, divided by 2 factorial. Are you seeing the pattern here? So a3, it's the third derivative, because we're finding the third one there, and it's divided by 3 factorial. All the way up to wherever you end, so you're, for the final term, that nth term, you're doing the nth derivative divided by n factorial. Sometimes they will tell you what degree to go to, like our e to the x and cosine x down there, they tell us what degree to go to, so we'll go to that degree. Sometimes they don't tell you what degree to go to, and so I think that happens more in homework. You'll want to go to at least degree 4 or so, but realize that these don't end here. They continue on and on forever, technically, so you can always end it with a plus dot dot dot, and you'll see me do that some too. So let's look at example 1. Example 1 is a more basic, it's more about the computation here, okay? Find the Maclaurin polynomial for f of x equals 2x squared plus 3x minus 4. Notice, what degree polynomial is this? This is a second degree polynomial, right? So that's as far as we can go as we do this, is we're going to be going second degree. It doesn't say it here. In my notes, I use p of x standing for polynomial. You could, use whatever you want to technically. I just don't want to get, I don't want to use f of x because f of x is already defined as something else. And so, in order to do this, we're going to have to find a sub 0, or a naught, plus a sub 1 x times x, plus a sub 2 times x squared. So in order to do a naught, and I'm just going to write out the basics right now, we're going to be doing f of 0 divided by 0 factorial. You guys do know factorial, yes? I've taught that to you somewhere along the line. Okay. Plus, so that's our constant. Then we're going to do our x to the first term, which means I'm going to do the first derivative at 0 divided by 1 factorial times x to the first. So notice it's the first derivative, it's 1 factorial, and it's x to the first. 1, 1, 1. And then we're going to do the second derivative at 0 divided by 2 factorial times x to the second. And again, because this is a second degree polynomial, this is as far as I can go. Let's see. Helpful side information. So we find a couple of derivatives on this one real quick. We have f of x, obviously. I would like to think basic calculus here. Do we know the first derivative of 2x squared plus 3x minus 4? Does that sound familiar? First derivative is 4x plus 3. While we're here, we're eventually going to need second derivative, aren't we? Derivative of 4x plus 3 is 4, and so that is our second derivative of the original function. Okay, let's plug some information in here. F of 0. What do I get when I plug 0 into that original function? Negative 4. Divided by 0 factorial has a specific definition. 0 factorial is defined to be, notice it's in the denominator, it can't be 0. If you type it into your calculator, Ross is going to find that 0 factorial is, if he remembers where to find
I would say if
factorial,
I could get to factorial,
Is it like
1.
1.
That's convenient.
Okay? So 0 factorial is a special case. 0 factorial is defined to be 1. Know it, memorize it. It's in the math menu somewhere. It is also one of your alpha shortcuts up top, like maybe alpha 3 or something. So somewhere up there.
It's in math, it's in the prog.
Okay, in math you have to arrow over to prob.
And I just put 4.
Okay, yep, okay. Plus, okay, f prime of 0. So first derivative evaluated at 0 is 3. 1 factorial. 1. Because officially you start the number, you multiply all the way down to 1, right? Well, 1 all the way down to 1, that's just 1. And then that's times x still. Second derivative at 0. What's my second derivative when I plug 0 in? 4.
I was still thinking the last one.
Okay, 2 factorial means we're going to do 2 times 1 officially, which is 2. X squared. Okay, clean that up. Negative 4 over 1 is negative 4 plus 3 over 1x is going to be 3x plus 4 over 2x squared is going to be 2x squared.
That's interesting. It's the same thing.
It is the same thing. Now, keep in mind, the Maclaurin what's the Maclaurin polynomial doing? It's writing a polynomial for the given function. In this particular example, our given function was a polynomial. A polynomial being those individual terms added or subtracted together, right? So, like, not the cosines, the e's, but just your basic x to a positive power. Those terms added and subtracted, that's a polynomial. So, of course, it spit back at us the same polynomial. Now, is it going to do it on the next 2?
No.
No, because the next 2 are not polynomials. They are different functions. Okay? So this is just kind of proof it works. Okay, ready to try the next one? Find the Maclaurin polynomial of degree 4. So notice right there, it's specifically mentioning degree 4 for f of x equals e to the x. So this means as we write this out, we're going to go up to x to the 4th. I'm going to write it out similar to how I started off last time. As you get more used to this, you might be able to skip that initial step I'm doing, and that's fine. But for the benefit of notes and us being beginners today, I'm refreshing my brain as I go too because I don't use this. You know, this is not something we see a lot. So, okay. So the first thing, if I write this out, basically, we're going to be doing f of 0 over 0 factorial. Plus, what am I going to do next? F prime of 0 over 1 factorial times x to the first. plus f double prime over 2 factorial times x squared plus triple prime over 3 factorial x cubed plus the fourth derivative, I don't know how to say f quadruple prime at 0 over f4 factorial x to the fourth. I honestly do not know.
Because it was like the 9th derivative.
I honestly don't know. You don't usually see that. I don't know that you normally see that. So I honestly don't know what they do. Unless they switch and just use numbers. I don't know. Got nothing there. Okay. So let's go ahead and work on cleaning this up. What is f of 0? What are we doing there? Means we're going to be doing e to the 0, right? And then I'm going to go ahead and write e to the 0 this round. But when we go back and clean this up later, anything raised to 0 power is 1. So that numerator will be 1. Okay? Over 0 factorial. What is 0 factorial, did we say? 1. So next round, that's going to be 1 over 1. So that's just going to be 1. Okay, derivative. What is the derivative of e to the x? E to the x. E to the x, we're substituting 0, and we're doing again e to the 0. 1 factorial is 1 times x. Obviously, I'll clean up later. What about the second derivative evaluated at 0? Second derivative is e to the x, so then it's e to the 0. What is 2 factorial? 2 times x squared. Okay. I was looking to see how I wrote this in my notes. I actually have it in 2 different ways at the end. So, third derivative at 0, e to 0. What is 3 factorial?
6.
3 times 2 times 1, 6, x cubed. And fourth factorial at 0, e to the 0. What is 4 factorial?
24.
Yeah, 4 times 3 times 2 times 1. So 24, x to the fourth. Now, this is degree 4. So we're stopping here. But technically, if they didn't tell us a degree, we could keep going. Or just do a plus dot dot dot. Okay, realizing it goes on. One way to write this, I'm going to show you 2 different ways, so you can kind of leave space to write 2 different ways, is to just clean it up. All these e to the 0s are going to be 1s, right? So I could write this as 1 plus 1x, or so plus x, plus 1/2 x squared, plus 1/6 x cubed, plus 1/24 x to the 24th. You could also write that as like x to the 4th. Did I say that wrong too?
X to the 4th, right?
Yeah.
You said x to the 24th. I'm like, huh?
Well, I turn around and Ross is just giving me this look, and I'm like, did I say something wrong? Did I write something
I
wrong?
figure you just said it and wrote 4th.
Yeah, well, unfortunately, I wrote it wrong also. So, okay. What I was trying to say is that this could also be written like as x to the 4th over 24. X to the 3rd over 6. Now, that is one way to write it. What I actually have circled in my notes, it depends on the situation. Like if you're plugging this into a calculator, it's probably easy to plug this version into the calculator. If you are wanting to leave it in a Maclaurin form, let's see, they would say 1 plus x still, but they would go back and leave the factorials on the other pieces. So they would leave it as x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. And that's what I actually have boxed in my notes. I'm not against the other one either. And I think it's helpful to know both forms, honestly, to be comfortable with either way there. Okay. Questions there? Think something I don't think I've ever done is graph these side by side, and I'm curious if it's going to be huge, very much similar or not.
Sergeant Ginnerbrecht Smiley thinks this for Monday, Tuesday, and Wednesday.
I'm sorry.
Algebra 2 comes back to test.
They did. They had a test this morning.
That's unfortunate.
That stinks to me. I'm just kidding.
Okay. Yeah, it doesn't come out exactly because the right side comes out exactly, but the left side doesn't. And I wonder if the farther you go, I can't say that. So there's e to the x, what you guys know is e to the x. And I'm not sure if you go farther. I don't know. I need to look into this. Because there on the right side, it's very much like e to the x. Obviously, there on the left side, it's not. But if you think about it, x to the fourth should have up and up in behavior. So what is it? The higher the power, the closer it gets? I don't know.
I was going to say, because this is just like our way of approximating it.
Right.
Because it is like.
And it might be, and honestly, if we look into it, because we're just working with writing the basics here. It might be if we look into it, and maybe I'll check the book after I finish the lesson here, that they put a restriction on x. Because this is a very good approximation of what x is bigger than 0 or negative 1. Obviously, when x is less than that value, it isn't. So, aha. Okay. One more. Then you actually have work time. You might need it, right?
Are you in our final?
Okay. Find the Maclaurin polynomial for degree 6 of cosine x. Okay. So degree 6 is what we are looking at. On this one, I tend to start off kind of with a chart to kind of gather my information. Because it's cosine, and that's going to go back and forth between cosine and sine and negatives and all of that, I usually do kind of with a chart. If we're going to be going up to degree 6, I'm going to need to know up through the 6th derivative, correct? And so I'm going to call that n. And we're going to start with 0 because zeros are basic. 1, 2, 3, 4, 5, 6. And I'm not saying you'd have to do this chart. You could work it all out separately. My middle column is going to be the nth derivative. So whatever n is, the derivative. And we'll plug in the 0 here in another column. So my f of 0, or the 0th derivative? I don't know. That's just your basic, right? So my basic original function in this case is the given cosine x. Okay? Now, when n is 1, that means I'm going to be finding the first derivative. What's the first derivative of cosine x? Negative sine x. When n is 2, I'm going to be finding the second derivative of cosine x, which is also just finding the first derivative of negative sine. So what's the derivative of negative sine x? Negative cosine x. Because the derivative of sine is cosine, so the derivative of negative sine is negative cosine. So basically you're realizing this middle column, I'm just going to be finding all the derivative of each one, right? So now the third derivative, well, what's the derivative of negative cosine x? Derivative of cosine is negative sine. So derivative of negative cosine is just sine x. Derivative of sine x? Cosine x. Derivative of cosine x? Negative sine x. Derivative of negative sine x? Did you notice something happening? It's going to repeat every 4, isn't it? Okay, when you do the derivative of cosine or the derivative of sine, it's a cycle of 4 because those negatives are in it. So once you know the first 4, you've done the work. Now the other column I'm going to go ahead and find is the nth derivative evaluated at 0. Okay, so this is all in efforts to just, when I set up my equation, we have all the information ready to go. So when I'm saying the nth derivative evaluated at 0, basically all these derivatives in the middle column evaluated at 0. So what is the cosine of 0? 1. What is the negative sine of 0? 0. Sine of 0 is 0. So positive or negative sine of 0 is 0. What is the negative cosine of 0? Yeah, if cosine of 0 is 1, it starts up at 1 on the graph, right? Then negative cosine of 0 is negative 1. Sine of 0? 0. Cosine of 0? 1. Negative sine of 0? 0. Negative cosine of 0? Negative 1. If my middle column repeats every 4, guess what? My derivatives repeat every 4. Okay? So, let's write this out. Okay. So, we're doing f of 0, which was, I already have it here, yes. F of 0 is 1 over 0 factorial, which is going to be 1. I'll write that in the next one. I am going to write a little bit, but I'm not going to write, as many rows this time. Now I'm going to do the first derivative at 0, which is 0 over 1 factorial x to the first. Again, we'll come back and clean up later. Plus, now I need the second derivative at 0, which is negative 1 over 2 factorial x squared. Are we okay with what I'm doing here? Stop me if we're not. Then I'm going to do the third derivative. So I'm going for my 3 row there, which is the derivative is 0 over 3 factorial x to the third. Fourth derivative at 0 is 1 over 4 factorial x to the fourth. Fifth derivative, 0 over 5 factorial x to the fifth. I did not space mine very well. And sixth derivative, negative 1, 6 factorial x to the sixth. What do you notice?
Every Every so often, it's just 0.
Every so often it's just 0?
Or every other is 0.
Every other? In cosine, notice all of my odd powers are 0.
I have a feeling sine is the opposite.
Okay, so notice my odd powers. So x to the first, x to the third, and x to the fifth all had a numerator of 0. 0 divided by anything is 0. So I'm not even going to write my odd powers. We only need the even powers. And your constant counts as an even power, just because it's every other one. So 1 over 0 factorial is going to be 1. Now notice, it's negative 1 over 2 factorial. So I'm actually going to write it as minus. And if I put it in the form and put x squared over 2 factorial. This is kind of an official form here. Notice my x to the fourth term is positive. So I'm going to say plus x to the fourth over 4 factorial. My fifth term is gone. My sixth term, notice it is minus x to the sixth over 6 factorial. We're done here because it said degree 6. In all honesty, I could keep writing without doing any more work. Do you see the pattern? We're going to skip all the odds are gone. It's going to be even powers only, and my sign is alternate. So we could keep writing past this. Okay?
So you said that in like the sine could be all the even powers. Sure.
I think so. Okay. I'm going off of a year since I've taught this. I'm trying to remember. But I think the sine ends up being all the odd powers. So like the cosine here was all the even powers. I think sine, instead of starting with 1, starts with x, and that's x to the third over 3 cubed, x to the fifth over 5 cubed. I'm sure you'll get to try that out in homework. The signs probably alternate also. Again, I'm going off of memory, and it's been a bit. Yeah, you'll find out soon enough. Okay? So that is your Maclaurin polynomial. We're taking this e to the x, the sine x, the cosine x, and we are turning them into polynomials. Okay? Okay. You have some work time. I would use it.